Hello, welcome everyone to our 2025 Monument Research Symposium. You probably all saw it coming in, but we do have merchandise outside if you out in the hallway if you're interested afterwards. Also, please eat more of the snacks on your way out. Take some home. I don't want to take it all home, so there's also a bathroom and a drinking fountain if you need to use it at any point during the presentation or afterwards. If you exit the auditorium and then I believe turn left. Keep walking down the hallway, you'll find it. My name is Zainab. I am the program coordinator for the Friends. We also have some other staff and board members with us today. We have Daniel, our executive director. He's doing our webinar. Thank you. And we have board member Terry, Jonathan, Isabel. Let me see if I missed anyone else. And then we have Joe, who is our student board member, also a presenter tonight. So the mission of the Friends of Cascade-Siskiyou National Monument is to support the protection, restoration, and conservation of the Cascade-Siskiyou National Monument through service, advocacy, and education. And yeah, so tonight we will get to learn about the research done in the monument mostly this past summer, but throughout the past year. And by this year's Friends Research Fund grant recipients. And thank you to Southern Oregon University for the generous use of their wonderful auditorium and technology. This would not be the same without their technology. So just to give you a little information about the Friends Research Fund, we are pleased to annually provide grants of up to $3,000 per application through our Friends Research Fund that supports research intended to enhance our understanding, appreciation, preservation, and protection of the Cascade-Siskiyou National Monument. Even though our grants this year are focused more on the natural sciences, we also love to see study areas such as environmental studies or education, sociology, arts and humanities, Indigenous studies, history and business, amongst others. If you have a good reason and it aligns with our mission, we would love to receive an application. Our 2025 grant cycle is open and we are accepting new applications until April 25th. If you or anyone you know is interested, you can find out more and download the application on our website. You can also talk to myself or Daniel about it after the presentation, after the symposium, if you'd like more information. So before we begin, I would like to do a land acknowledgement. So I'm going to do that now. We acknowledge that we call the Cascade-Siskiyou National Monument and surrounding area has been the ancestral lands of Native tribes since time immemorial, including the Takelma, Shasta, Lakawa, Cayuse, Cow Creek, Umpqua, Umatilla, Walla Walla, and Modoc. All Native peoples in what is now known as Ashland endured genocide, forest removal, and broken treaties with the U.S. Their living descendants are now enrolled across several of Oregon's federally recognized tribes. I ask forgiveness if I forgot anyone. And I encourage each of you to visit the tribal websites to hear Native people's history in their own words. In addition to this acknowledgement, I would also like to give you some action items that you can do to support Native communities. One, we can give land back to tribes. If this is something you are interested in learning more about, the website for the Confederated Tribes of the Grand Ronde has information. We can protect the environment and salmon. Tribal cultures depend on them. We can insist that the United States respect tribal sovereignty and uphold its trust responsibility to tribes, which includes appropriate levels of federal funding to support tribal needs. Many promises to tribal nations still need to be kept. We can elect officials that understand tribal governments, relationships, and laws. We can invest in tribal economies. There are many, many ways to do that. I encourage you to do some research on that. We can challenge and reject all stereotypes about Indigenous people. We can insist that our children and grandchildren are taught accurate information about the histories, cultures, and contemporary lives of Indigenous peoples in our school system. We can inform ourselves about issues impacting Indigenous communities and speak up. And finally, we can educate ourselves about the atrocities committed against Native people in Oregon and the entire United States, but also about the rich and unique tribal cultures. A good place to start is simply going to the tribe's website and start learning about their history. Thank you. So after each presenter has finished, there will be a brief opportunity for questions. So please hold your questions until the end. If you are attending virtually, please put your questions into the Q&A box, and we will try to get to as many as possible. And without further ado, I would like to welcome Dr. Jacob Youngblood, Assistant Professor in Biology and Faculty Advisor to our first two grant recipients.
All right, welcome everybody, and welcome to SOU. Thank you to Zina for that introduction, and thank you to you all for being here, and to Friends for hosting this wonderful event and hosting these grants that have supported research in the monument and our students. And so in a moment, we're going to hear some talks from students that are going to be the finished product of research. And in that finished product, it's often easy to forget that a lot of work, day-to-day grinding went on for this research. So I wanted to highlight, I had the pleasure of working with these two scientists, Joe Bowers on the left, Jacob Flory on the right. It's our first field trip of the season, July 2024. Safe to say, although Jacob might disagree with me, that they knew very little about grasshoppers in this moment. And then because of the support from Friends of Cascade-Siskiyou National Monument, they did a lot of work over the summer and learned how to do a lot of things, whether it's how to be observational and record detailed observations and field notes, how to collect data, how to interpret, analyze that data, how to communicate their results to a public audience. And along the way, we also had a lot of fun doing all of those things. This one is at least one staged photo. Part of work there. And so all of this hard work that goes into it will culminate in presentations you see today. But outside of the research, I just want to highlight the most valuable thing in my view of this as the experiences that our students have. And not only are they advancing knowledge about the monument, they're learning transferable skills, help them in their future careers, whatever that may be, whether it's in biology, geology, environmental science at all. And then at the end of all of that, we get to celebrate at the end of the field season and have culminating events like this one, where students get to take all of that hard work and share it with you. So I'm really grateful for all of you being here. I'm grateful to Friends for supporting the research. I'm more than anything grateful to Friends for supporting our students. So thank you all so much. And without any further ado, please join me in welcoming Jacob Flory and Joe Bowers.
So hello, everyone. My name is Jacob Flory, and this is Joe Bowers. And today we'll be presenting our findings that we found through the monitoring the abundance and diversity of various grasshoppers within the Cascade-Siskiyou National Monument.
All right, so why are we studying grasshoppers in the monument? The monument, as you all may know, it has a convergence of multiple ecoregions and many different microclimates in which lots of organisms inhabit. This includes grasshoppers. And so, as many of you also probably know, it's a really biodiversity hotspot in the monument. And so there's some species and different animals that we know very well, such as some birds, butterflies, maybe fungi, but there's many other understudied groups, such as grasshoppers, that we want to know more about. And so with that too, we can study these grasshoppers, both populations as well as species, and learn more about how they change over time, especially with the environment and how it changes. And then another thing we can do with this grasshopper research is kind of use these grasshoppers and the data we get from them to be sort of ecological indicators, understanding essentially what's changing with grasshoppers could also be changing with other organisms, or just showing general environmental changes in the monument.
Yeah, so our first question is, what are grasshoppers? And well, we distinguish grasshoppers from other members of Orthoptera through the following criteria. For one, grasshoppers typically have short antennae and short ovipositors. As you can see, some examples of individuals outside grasshoppers. First of all, crickets at the very top typically have long and thin ovipositors, sort of little tubes that extend beyond their abdomen. Next, below that are sort of katydids, and they typically have very long antennae, which typically extend past the entire length of their body. And then looking at grasshoppers themselves, we see some variation within their clade of Acrididae, where they're divided into three main subfamilies that we found within the monument. The first was Melanopinae, the spur-throated grasshoppers, one of the most abundant species we found within the monument. Next is Gomphocerinae, the slant-faced grasshopper, one of the least abundant species we found within the monument. And finally, Odopodinae, the band-winged grasshoppers, which is one of the species we found to be the most prettiest, because not only do they have bands on their wings, they also come in a variety of colors, such as yellow, green, and pink. And if you would like to learn more about these subfamilies, feel free to check out our brochure guide, where we also delve into sort of these subfamilies as well. Now, in order to sort of capture these grasshoppers and learn more about their diversity, we went through a few methods at the different sites throughout the monument. First, we established our 5 sites across an elevational range of over 4,000 feet. Then we visited each site weekly throughout the summer period, where we performed 200 net sweeps per visit. And then finally, we recorded the number of species, number of individuals, the sex, life stage, and the temperature of each sites. And throughout the years, we've actually added an additional site, so we were more able to capture the elevational gradient this year.
All right, so I'm going to go right into some of these kind of main findings that we had studying these grasshopper populations and these species. So one was that the grasshopper abundance, it tended to be highest at these mid-elevations. If you look at the graph here, you can see along the x-axis is the ordinal days of the year. So for your own reference, if you go between like day 200 and 220, that's like July, mostly kind of later July. And with the y-axis, you see the individuals per 200 sweeps. So really what that's saying is the number of grasshoppers that we had caught, each sampling visit that we had to each of these sites. So each site is represented by a different colored line here. Overall, you could see this kind of peak in late July, where the number of these grasshoppers is the highest out here along all the sites, and then it decreases in abundance after this point. Overall, you could see kind of a elevational variation between these sites, but especially the site at like 4,800 feet, for example, that green line that you could see kind of soaring above these others really showed a high number of these individuals and some of these other mid-elevation sites as well. Another thing that we found was that the grasshopper diversity was highest at these mid-elevations. So not only the number of individuals, but the number of species that we were finding tended to be more along these mid-elevation sites. So you can see this graph here along the x-axis. Again, this is the ordinal day of the year, but this time the y-axis is different to show the species richness per 200 sweeps. Essentially, it's saying how many different species did we find at each of these sites per time we visited. And so really, once again, you see this kind of late in July, it has a maximum number of species for almost all the sites, except for the one at 5,400 feet. You could kind of see it actually, it increases until the rest of our sampling season. But for the most part, it kind of slopes off after this, and you can see there's kind of a difference between the sites and how much it slopes. But yeah, and then so anyways, like I talked about earlier with that abundance, we really see a lot of elevational differences between this, specifically these mid-elevation sites having this greater diversity and number of individuals. All right, and so one site that I like to talk about, this is our lowest elevation site that we sampled at. This is called Sampson Creek Preserve. It is around 2,300 feet in elevation. It has a daytime air temperature range between 19.7 and 35.8 degrees Celsius. So it's pretty hot there, pretty hot and dry. It also had our lowest species richness out of all the sites in which we sampled. So you see, we say a species richness of 6. That means that we had identified a total of 6 different species along this sampling time that we were out there. And a most abundant species for this site is actually Melanoplis devastator, which Jacob is going to get into now.
Yeah, so Melanoplis devastator, also known as the devastating grasshopper, is within the subfamily Melanoplinae, which means individuals of this species will also have a noticeable spur upon their throat. And this species in particular is known to be a major pest in California and sort of a more minor one in states like Oregon and Washington. They're known to be highly abundant in low elevation foothills, including our most newly added site, Samson Creek Preserve. And they've been known to be capable of forming migratory swarms. Now, the interesting thing about this grasshopper is that it's fairly associated with highly disturbed locations. So throughout the years, if we see an increase in these species, we could also maybe assume that perhaps the level of human disturbance within the monument may have increased as well. And I should also mention that with the species slide, there will also be a species abundance graph with them as well, which you can sort of look at to sort of understand how the abundance of these grasshoppers have sort of changed throughout the sampling season.
All right, so another site that I want to discuss, Shale City Meadow. This is more of a mid-elevation site in which we sampled at. It's around an elevation of 4,800 feet and has kind of a daytime air temperature range between 15.8 and 31.3 degrees Celsius, so a little cooler than what we saw there at our lowest elevation site, Samson Creek Preserve. The species richness here is 10, meaning that we documented 10 different species here at this site, a little higher also than that lowest elevation site as well, but not the highest out of all the sites that we will be seeing here. And overall, though, if you remember from those graphs I showed earlier, the number of individuals here was the highest out of all sites. So this was that green line at 4,800 feet that was really soaring above the others. So it may be that it has this leafy, grassy vegetation here that's really supporting this high number of individuals, but it really stands out here as a site. And so another site that's close to Shale City Meadow is Shale City Vista. This one's just slightly higher in elevation than it. It's at 5,200 feet. It's also along Shale City Road. The daytime air temperature range is relatively similar, 17.6 to 29 degrees Celsius. And the species richness is also the same number, but it should be noted that although we found 10 species here, as well as at Shale City Meadow, some of these species are different. And so, yeah, what we see here too, a little bit difference in vegetation where it's more shrubby and woody with some sparse grasses. And so this site, although it had pretty good species richness, it did have a lower relative abundance of these grasshopper individuals compared to Shale City Meadow. One other thing to point out, I have a picture of the Fontana grasshopper. That is a grasshopper that we found at this site and some of the others. And Jacob's going to discuss this grasshopper as well as Melanoplis ascensus, grasshopper, which I had pictured in the previous slide. I didn't mention it though, and give you guys some more information on what they're all about.
Yeah, and so as Joe mentioned, Melanoplis ascensus is here, which is also known as the Shasta short-winged grasshopper. It's also within the subfamily Melanoplinae, so we'll also have a spur at the beginning of its throat. It's the most common species in the monument, and so if you go out there and try sweeping for grasshoppers yourself, it's very likely this is the first one you'll find. It's known to be endemic to southern Oregon and northern California and appears to prefer grassy and leafy vegetation. It's also worth noting that although we sort of categorize this as one species, it's known that this species varies widely in its internal genital morphology. So some of you may count this as multiple species instead of just one. And the other grasshopper that was mentioned was Trimeratropus fontana, also known as the Fontana grasshopper. This one is within the subfamily Odopodinae, and as you can see with its wing shown here, that it has a dark band that runs across its inner wing. And though it has that band, other species of Odopodinae, their wing is a bit more pronounced than this one. This species makes an interrupted buzzing sound while flying and is fairly common in low elevation environments and forest openings. It also appears to prefer to reside in open soil and rocky outcrops such as asphalt. For this reason, this species is a bit more common outside of the monument. And if you're walking around Ashland or Medford during the summer months, be sure to keep an eye out and you may spot this unique species.
All right, so another site that I'd like to discuss is Hobart Bluff Trailhead. This was our second highest elevation site, found at around 5,400 feet. The daytime air temperature range, once again, it's 15.7 to 28.5 degrees Celsius, a little bit cooler than some of those other ones we were seeing. But what really stands out about this site is the species richness. We documented 13 different species here, higher than any other site in which we had sampled. We really recommend going here if you guys would like to explore some grasshoppers for yourselves. It's a really easily accessible place within the monument to go and see quite a few different grasshopper species, as well as there's a relatively high abundance here of individuals as well. So there's a really good chance you're going to see quite a few different grasshoppers. One other thing to mention is that this is one of the 4 sites in which we saw the endemic Siskiyou short-horned grasshopper, which Jacob is going to go into more detail about now.
Yeah, and so the Siskiyou shorthorn grasshopper, also known as Chloealthus spasma, is a pretty unique species that was pretty important during our sampling procedure. It's within the subfamily Gomphocerinae, so you may notice that it has a lot more of a slanted face than the other grasshoppers we've mentioned so far. It's endemic and sort of listed as more of a sensitive species within the monument. Its active season is within July and September and is usually found at more of the mid to high elevations within the monument. Now, some notable findings we found out about this species in 2024 is that this was the year we found the earliest sighting of it during the sampling period. And we also extended its distribution range eastward, as we found one of the first individuals within Klamath County. Now, this sort of shows that the more research we do within the monument, not only will we find more species within it, but we'll find more information about the species we already know.
All right, so the last site that I'm going to discuss is Surveyor Mountain. This is our highest elevation site, found at around 6,400 feet of elevation. The daytime air temperature range here is between 8 and 29 degrees Celsius, so you can see that it actually drops a bit below what some of these other sites were when we were looking at these temperatures in the daytime. The species richness here is also 12, so that is relatively high, not quite the highest though, as we saw with Hobart Bluff Trailhead. And another thing is the abundance is relatively high too. Some species of interest here include Melanoplis organensis, as well as Melanoplis godeni, which Jacob's going to get to here in just a second. But one other that I would like to highlight real quick that we don't have a whole lot of time for is the slow mountain grasshopper. This one is one that we only found at this site. It's a wingless grasshopper, and I just thought it was pretty cool, so I'd mention it.
So the two grasshoppers that Joe mentioned were Melanoplis godeni and Melanoplis organensis. Now, the unique thing we noticed about these two grasshoppers, which we found up in Surveyor Mountain, is that they appeared at very different times of the sampling season. We first noticed it with Melanoplis godeni here, which sort of appears at the very beginning of the sampling year and sort of disappears for the rest of it. And then there's Melanoplis organensis, which sort of appears at the very end of the sampling season, which was another unique thing about it. So this tells us that the monument houses not only multiple species, but multiple species that vary within their time of emergence.
All right, and so now just to go over kind of our overall conclusions for our research. Like I showed earlier with some of those graphs, the diversity and abundance tended to be highest at these mid-elevation sites. Overall, we documented a total of 24 different species across 15 genera over the 2-year monitoring period in which this research occurred. The species, they vary in their distributions, their seasonal timing, as well as their habitat preferences, as you saw a lot with some of those species slides that Jacob was going over. And we'd like to leave on the fact that trends are better understood with long-term monitoring. And so although we have some really good data now that we really are starting to learn some things from, if we continue to do this monitoring, that's when we're really going to be able to see some more of these long-term trends and make a lot better predictions as to what's happening with grasshoppers, as well as other organisms in the monument or the environment in general. And so, thank you so much for listening to our presentation. We'd like to acknowledge the Friends of Cascade-Siskiyou National Monument who generously funded our research and really made it possible. We'd also like to thank Southern Oregon University and Tim McNary for helping us identify some of these grasshoppers that were really difficult to identify. We also gratefully acknowledge the Selberg Institute and the Bureau of Land Management for granting access to some of these field sites, as well as for their additional logistical support. So thank you all for listening to our presentation here. We'd love to answer any questions you have about our research or about grasshoppers in general.
Yes, you there.
How does this compare to other sites like in California, maybe Northern Oregon? Do you guys have a sense of how, in terms of species diversity? And I mean, the monument is unique for that, but I'm just wondering how it would compare.
Well, we haven't made any direct comparisons with any sites outside of the monument, but we think it's safe to assume that the relative diversity of grasshopper species within the monument is relatively high, since it's sort of a convergence of these multiple ecoregions that sort of multiple species can inhabit. Yes?
Questions. One is whether the correlation you're seeing between species diversity and elevational gradient is common in other sites and observed in the literature, basically. And then I was also wondering how much correlation is there between grasshopper diversity and either perennial grass, native perennial grass coverage, or form diversity.
So this
was what you alluded to in your presentation as being important.
Yeah, so this question was asking whether how we could attribute sort of the correlation of these different elevational gradients with the types of grasshoppers we see. And as well, she's also asking that whether sort of the presence of the grasshoppers could be, I guess, correlated with the sort of grasses we see at each of the monuments. And we sort of find when looking at each of the distinctual grasshoppers that typically, we find that high elevation species that are typically recorded to be in high elevations, such as the sort of Bradynotes obesa, typically have also been found at sort of these high regions as well, and sort of like that, Melanopus devastator have also been found sort of at low elevation sites. Now, whether the diversity is corresponding with, I guess, sort of the plant species that are found there as well, we also sort of see that, I guess, these grasshoppers also have sort of nutrient preferences as well, where sometimes grasshoppers can be associated with host plant species, though I guess as to whether the diversity is correlated with the diversity of plant species or the inclusion of sort of grasses, we sort of see that Shale City Meadow, one of the sites we looked at, sort of had a relatively low diversity of grasshoppers. Mm-hmm. And we also saw that the main bit of difference between the meadow and the vista is that the meadow had really low diversity, but had also sort of a low diversity of plant species as well. So I guess maybe.
I would also add here that essentially there's some species that are really more specialists in environment and others that are more generalist. And so you see like some like Devastator, which Jacob talked about earlier, that does really well in these human disturbed environments. You see others, Chloealtis spasma, not so much. This one seems to be more of a sensitive species and might be thriving, as you could see, at some of these higher altitude sites. And we're not too sure really though also on those like native plants versus which plants exactly, but that's something where if we get to research these more and more, hopefully we could learn more information about that type of thing. All right.
Yeah, I don't think you have to repeat this one because I'm pretty close to the mic. This is a question from the Zoom audience.
All right.
I think it ties a little bit into the question that was just asked, but can you say a little bit about the role or niche of the grasshoppers in the sense of predatory prey relations, known effects of absence, etc.?
So the known presence or non-presence of predators within the population, we didn't really sample whether there was a presence with these sort of any predator species that may be feeding upon these grasshoppers. So I'm not too sure about it. Joe, do you have any thoughts to add?
I would say primarily we're seeing a lot of birds and maybe small rodents are also things that are eating grasshoppers. You're really, we like he said, we haven't sampled anything as far as the predators, but in any literature you read, a lot of these birds, especially ones that tend to dwell around meadow, kind of grassy areas, are eating. It can take up. I want to say I read in one paper it could be up to like 75% of their diet is grasshoppers and things of that nature. So if you guys like birds, grasshoppers are helping with their survival as well, being a food source. Yeah. Okay. Yeah.
I saw in your data there was like a little gap where it said like wildfire or smoke affection. Was that during that time were you not doing sampling due to the smoke condition, or did you actually see zero grasshoppers that entire
No, that was when the air quality outside was so low that we felt it was important for our health that maybe we don't go outside and do this strenuous sweeping for the day.
Yeah.
Any other questions?
Right, Daniel.
Yeah, I remember one of the presenters who worked on this similar project last year described grasshoppers as like one of the most prolific grazers in the West. And that was like a really a point that went home with me. And I'm just curious if you've thought about doing any studies in relation to the other big grazer in the West, cattle that are present in some of the sites. They're present in some of the sites you sampled and some of the ones you didn't. Maybe you just have some anecdotal observations of that. They're only out certain times of the year. Yeah.
I would definitely say that would be something we would love to study. With Shale City Vista and Shale City Meadow, for example, that's along Shale City Road. I believe Shale City Meadow is actually open to grazing. I remember seeing cows there at one point when we were out sampling. Shale City Vista, I actually don't think there are cattle there. Something kind of interesting, though, is that we actually did see a higher abundance at Shale City Meadow. Now, of course, anything I'm saying here is just speculation. This is not any sort of fact that you should take home and share with other people. But really, there were more grasshoppers in this grazed area. But perhaps it's because we have some grasshoppers that are specializing on maybe some of these grazed plants. Also, there could just be differences in moisture in the environment. Maybe that's why they're letting the cattle graze there specifically, because the food source is better, I guess, for the cattle. But yeah, it would be really cool. We'd love to study more about these grazed versus ungrazed sites in the monument. We think we definitely would end up seeing some differences, especially if you did a long-term study and really focused in on that. Oh,
yeah.
Do you see your works, your sampling work changing?
Well, not directly, but we do see that since this is a long-term monitoring program, especially that it will be continued in the future. So we do see it continuing. And
yeah, I think I can add. I think Jacob and Joe are gonna go on to bigger and better things, and so you'll read about them in the New York Times or something like that. But yes, I'll still be here and still hoping to monitor grasshoppers for many years.
all right, and then Daniel.
I have another question from the audience online. Are there any of these species more associated with crop damage? I live near the monument on the California side. I was surprised at the amount of grasshoppers eating everything last summer.
well, like I sort of mentioned before, Shale City Meadow appears to be a site that is more frequently grazed, and we find a higher abundance of species of grasshopper there. Though we also find that a majority of those grasshoppers are a single species, Melanoplis ascensus, which may be that this species is sort of taking advantage of either the vegetation that's being grazed on or that it may be being grazed.
Yeah, Devastator also, that's Jacob had brought that up in another one of his slides on Melanoplis devastator. That one is known to be somewhat of a pest, especially in California, less so in Oregon and Washington. And it is capable of forming these kind of migratory swarms, although I don't believe it's actually considered a locust, which we could get into. That would take a while. But yes, so there are some that tend to kind of specialize as being sort of pests. The one pictured here, Chloealtis spasma, if you see it, please do not harm it. It is not a pest. This is a really kind of rare special grasshopper that's endemic to the monument. So yeah, and any grasshoppers in general, please respect them if you can. All right.
Okay, well, thank you.
Thank you. Yeah, thank you so much.
If you are interested in the little the guide pamphlet that they made, those are available up on our table up there, and we do hope to start more widely distributing that as well. So I would like to invite Dr. Jad Delura to the stage, to up here to introduce Erin Medler.
You. Well, as you probably know, we no longer have a geology program here.
Scoot, stand in front of the computer a little bit.
Over here? Okay. Can you hear me?
Yeah.
You can hear me. Okay. Although we don't have a geology program here at SOU any longer, fortunately, there have been students at the University of Oregon who were interested in the monument. So I've been able to Shanghai one or two or three of them since 2012 to do some research in the monument. Erin is the latest of these students, and I probably should say for your sake, the best working in the monument. Did that go to your head? Well, the monument's pretty much been mapped in reconnaissance, and there's one little section that was still remaining in the southeast portion of the monument itself, and that's where Erin has done the work, the geologic work. There, the rocks have what are called Western Cascade rocks, which are older rocks and slightly deformed, but not badly so. And then some younger high Cascade rocks that lie over the top of them. So this particular area that she's working and that Erin's working in is an area that has these types of rocks. So without further ado and blather, Erin.
Hi, I'm Erin. And as John explained, the two of us explored the geology of the southeastern corner of the Cascade-Siskiyou National Monument this last summer. Just before we get started, I do want to thank the Friends of the Cascade-Siskiyou National Monument and the Bureau of Land Management for financing this study and others. Couldn't be here without you guys. Really cool stuff that you're doing. So at the beginning of the summer, we wanted to update the geologic map in the red southeastern corner of the map over there. We wanted to get some geochemical dating, which would allow us to kind of have a better understanding of the chemical makeup of the rocks as well as age them. And then we wanted to determine kind of the general geologic history of the area, kind of figure out what happened millions of years ago. And then we also wanted to find springs and bogs and other natural features. Here's a kind of time scale of the area. As Jad mentioned, the Western Cascade rocks are the much older rocks, and they include a couple different formations that overlap each other, which makes it kind of hard and confusing to date them in the field. And then the much younger rocks that are between about 6 and 1 million years old are the units that we specifically wanted the geochemical analysis of. So once we were out in the field, we relied very heavily on the soil in the area because it wasn't always super easy to, we couldn't always rely on the outcrops themselves. So we would find differences in the soil, like tufaceous based soil was usually like gray, and one that came from more volcanic rocks was probably red or maybe a little bit muddier. But basically what we saw is a northeast dip and steep northwest trending fault, which pretty much is a compass direction of like a plane orientation. For those of you who are unfamiliar with the geologic mapping of that, which basically reveals a lot of fractures and an overall long-lasting zone of weakness across the area. And earlier analysis done by Jad and some of the other students show that this continues further to the southeast. And for some of the formations that I didn't mention last time, the Wasson and Colston, the Colston, one of the ways that we identified that was by using these volcanic facies that are kind of covered by this. It's okay. Basically, the alluvial facies, which is sweet, thank you. Oh god, magic. Okay. Yeah, so basically, there's a scheme on the side that basically shows the different areas that these volcanic rocks are found. So alluvial facies was closely related to the Colston formation, and the tuff is related to the Wasson. So we use those combinations to kind of make mapping easier. Uh-oh. Aha, okay. So this is the map that we put together. I don't know how well they show up, but the blue dots kind of by the bottom of the, what is that, on the right and up along the top there, those are all springs that we found. And then the black lines across are showing those fractures and zones of weaknesses that I was talking about earlier. Which is also where a lot of the newer, younger intrusions are happening, which is the red and yellow formations that we were looking at. We also found a lot of springs and bogs. So essentially, they're natural forming along springs are formed naturally along fault contacts, or where fractured rock is above a shrink swell clay. And basically the difference between shrink swell clays and these fractured rocks is that the shrink swell clays will hold water like within them, and rocks not so much. So if a rock is sitting above this clay, it kind of will form a reservoir, and water will come out of it. And then bogs are more temporary. They're created by snowfall and rainwater, and tend to evaporate kind of early mid-spring. This is one of the areas that we were looking at, Jenny Creek Canyon. The part that I have highlighted in brown is the basalt of Pinehurst Inn, which is one of the younger units that we were looking at. Overlying some of the Roxy lava, which is closer to about 30 million years old. And I don't know how well you can see, but the line between them is an unconformity, which is basically just a loss of geologic time due to a plethora of reasons. But this is kind of, I'm going to be talking more about Jenny Creek. So this is sort of what the area looks like. So we think that there was an ancestral Jenny Creek that slowed slightly east of where it is currently. There were western cascade obstructions of basalt and other things that kind of intruded into the creek. And then once the lava of Pinehurst Inn was flowing, it got caught behind these obstructions and kind of pooled over. And in the top left, you can see the difference between the like more yellow rock versus the black stuff on top. Basically is evidence of lava being quenched in water while it's flowing. And yeah, the lava, once it finished pooling into Jenny Creek, eventually flowed over into Agate Flat, which is kind of northwest of Jenny Creek. Agates are very rare in the High Cascade, not something that are generally seen. So essentially underneath Agate Flat is more of a western cascade, like lying underneath it. There were exposed volcanic rocks that were covered with this basalt and variations of agates were made. Excuse me. Essentially, silica-rich water would pool into these cavities and form agates, which I think are pretty cool. Once we were done out in the field, we had to take all of our samples to the lab. Radiometric dating was done at OSU's lab, but for the sake of money mostly, we did a little bit of preparation with our super high-tech mortar and pestle. Basically, we would just we crushed the rocks, and then we melted them in the furnace until they made these glass beads. And then we would crush the glass beads again and then melt them again for the sake of getting the chemical makeup really homogeneous so that it would be easier to get the geochemical analysis from OSU. And this is what we got, which looks a little crazy, I know. But essentially what we're seeing is the x-axis is silica content and the y-axis is alkali content, which probably doesn't mean a whole lot to you guys, but essentially the much older rocks that we sampled, the Roxy and the Wasson, had a much higher silica content, whereas the much younger, like pink and brown basalts and andesites had a much lower silica content. So there's kind of a trend of decreasing silica throughout the area, which could mean something probably. The different compositions also indicate how well a rock holds up to weathering, like how strong they are essentially. And yeah. Here's just the map again. You can kind of see the brown flow is the Jenny Creek stuff that flowed into Agate Flat. Yeah, so we were able to finish mapping the area. We have a better understanding of the chemical makeup. We have extended our understanding of the zone of weakness, as well as finding springs and bogs. Yeah, that's it. Thank you again. I did not make a question slide. So, sorry about that. Questions?
I was just curious about so is you showed that graph and.
This one?
It could mean something, there's one, and then it got me really curious as to what it could mean, I guess what causes like, or is it silica on the x-axis
Yeah.
there? What causes variation in silica among different rock types?
So technically every volcano has a different like chemical makeup, like it's like a fingerprint almost. I'm not super familiar with what it would mean unless Jad has anything to say on the topic.
I always. Basically, what you're seeing there are different rock units. And they're erupting from different magma chambers, hence the compositions are different. So you take a look at the blue dots and the sort of ovals there. Those represent primarily volcanic eruptions, like you can see at Mount St. Helens. And that composition is very high in silica, also high in volatiles, CO2, water. So the explosions are quite spectacular. But you take a look over on the lower left side of the diagram, and you see that silica content is lower, and the magma itself that gives rise to the rocks is more sluggish and doesn't have as high a gas content. So that is prone to producing different lava flows of slightly different compositions there. So this little graph right there, just a way for us to characterize things, such as you characterize grasshoppers versus different colors and shapes and things such as that. And that allows us then to communicate to other geologists and they, obviously what's going on.
Yeah, sorry. I presented this last week to my geology class and they were all like, good job, Aaron. This totally makes sense. Yeah.
It's great, very engaging. Question from the Zoom audience says, great talk. Could you say again where the agates came from and how they were formed?
Yeah, so agates essentially form when there is space in like if there's cavities in a rocky area and silica rich water will kind of seep into these holes and start crystallizing. So it's and generally they'll have different stages of crystallizing, which is how you get the different like on this one here you can kind of see it's got like a crust to it. Which just means that like a different amount of silica was crystallizing around the corner and then as it got further to the middle it had different content, different temperature probably, which leads to the no agate will look the same kind of deal. Yeah.
About the springs you found, and if there are any particular like geologic signatures that seem to consistently show up in the monument that are associated with where those springs are.
Yeah, as far as the springs went, it was mostly if there was these shrink swell clays underneath rocks that had fractures in them. So I guess you can kind of see in the top, what is that? Top left. There's groundwater already there, and since water won't percolate as quickly through the shrink swell clays, it'll kind of build up on top and flow out through these fractured rocks. As far as on the map itself, is if there's any correlation, they kind of tend to form at the edge of the basalt of Pinehurst Inn. I don't know if there is. Jad, do you have anything to add to that?
Not all the springs are shown on the map, just a few of them. But you commonly find them where there's a difference in the percolation, say at the upper rock that might be fractured, as she said. And then the rock beneath it is weathering to clays, and that just forms a relatively impermeable layer. So wherever that contact is, you'll have springs. We didn't show very many along the canyon side, which you can see outlined. If that Jenny Creek goes down where the yellow shows. There are lots of little springs right there, especially in the spring. At the contact between the older rocks, which are weathering to clays, and the younger rocks, which are fractured and allow percolation.
Yeah, it is seasonal as well. There won't be, not all springs will be there year round. Yeah. Any other questions? Yeah.
Wasn't really a topic you mentioned, but stepping back,
Mhm.
is this area under compression or is it neutral forces in this region?
Yeah, I would say it's kind of it's a zone of weakness is what it's called. The black lines on the map show like faults. So there's movement along these faults. And it's I guess separating is probably the best way to say it. Which is allowing the volcanism to kind of seep up in between these fractures and these breakings. As far as like compression goes, it's more like kind of sliding along itself.
Yeah, this part of the monument, there's a lot of sort of lateral motion, not very much, but a lot of fracturing. You get to the eastern part, that's basin and range sort of extension going on. So this part right here is not really in the basin and range. It's more where the sliding is occurring. And there's up and down motion too.
Yeah. Great. Thank you guys so much.
Thank you so much, Erin. We are now to our final presentation, and I will invite Dr. Karen Mauger to introduce her students.
All right, so it is my great pleasure to introduce Sean and Andrea, who will be giving our last talk for the night. I've been working with SOU students for a few years now to try to monitor wildlife use of the interstate that cuts through the monument's southwest corner. And this work was accomplished together with ecologists from the monument and a lot of student volunteers and capstone students. And this year I said to Andrea and Sean, we're going to have summer funding. We're going to professionalize this thing. And with the support of the Friends of the Monument, we were really able to do that. They worked countless hard hours early in the morning before the heat was too bad, and many hours looking through tens or hundreds of thousands of photos and videos that they collected. So Sean is a recent graduate of our environmental science and policy program here with minors in biology and certificates in geospatial science and wildlife ecology and conservation. He started work on this project as his capstone last year and actually won the best capstone award. And Andrea is a current senior in our environmental science and policy major with a minor in math and a certificate in wildlife ecology and conservation. And I'm super appreciative of all of their hard work to keep this monitoring program going. Here you go.
Hello, everybody. I'm Sean Johnson.
And I'm Andrea Osborne.
And this is our presentation on wildlife camera trap monitoring in the Cascade-Siskiyou National Monument. Oop.
All right. Before we get into the science, we'd like to thank the Friends of the Cascade-Siskiyou National Monument for this opportunity. The I-5 Corridor Camera Trap Research Program has been going on since 2021, and one of our biggest lacks in data is those summer months. This is a very student-fueled project, with often students going into the field to get data and students combing through the images and videos like Karen highlighted. When summer rolls around, often students go home and there is a lack of funding to provide that job incentive to stay. Part of the money went directly to me and Sean for a summer job to do this research. Second, funding also provided some much needed supplies to continue this program. Things like SD cards. This is what our cameras use to hold the images and videos that they get. And these are your standard SD cards that you guys use for cameras that you might purchase in a store. SD card organization. As this project has gotten bigger, it's imperative that we keep our data organized, and SD card organization allows us to understand what cards can go back into the field and what cards still need to be uploaded to our drives. Batteries. Our cameras run on batteries. Without batteries, we don't have a program. So getting money to be able to purchase these was necessary. And finally, hedge trimmers. One of the most annoying aspects of this project is vegetation blowing in the wind and causing our cameras to go off. Often we would have to clear the field of view of these cameras, and this was done by hand, which, as you can assume, this is a long and tedious process. So getting hedge trimmers was a much needed relief from bending down and hand weeding all of our areas. Second, some basics that you need to know before we go into this talk. If you're sitting here, I hope you know about the wildlife crossing they are trying to implement at Mile Point. Yes, let's do a little, that's amazing. This will be implemented at Mile Point 1.7 on I-5. This will be the first ever wildlife overpass on I-5. And as of this year, we have gotten funding for this project, but it is currently on freeze. Now we still have hope that this will be implemented. A picture of what the wildlife crossing will look like is up on the screen. And crossings like this allow wildlife connectivity and lower wildlife vehicle collisions. ODOT estimates about 6,000 deer and elk collisions per year in the state of Oregon. And where this crossing site is a deer and elk collision hotspot. Now, if you live here, you know we hit a lot more than deer and elk, and those stats are only for those species. Second, me and Sean will talk about camera traps and captures, and these are specifically wildlife trail cams that we have up and down the I-5 corridor. When me and Sean talk about captures, we are talking about images and videos. We are not handling these animals. We are just taking pictures and videos of them going about their day, that when they pass in front of these cameras, they trigger it to take an image or video. Up on the screen is SOU2, which is located in the Mariposa Preserve and is a standard for our camera traps. The wildlife trail cam is placed within a lockbox that then is strapped and locked to the mount. SOU2 is mounted on a tree, but we have them mounted on bushes, poles, fences, posts, just anything that doesn't move to trigger it to take a picture. We also say wildlife a lot in this talk. And when we mention wildlife, we are mainly talking about mammals and one bird species, the wild turkey, that we also monitor. Specifically, these cameras are also locked to whatever they are mounted to discourage humans from stealing them. These cameras cost a pretty penny, so losing one would be pretty annoying. And then also to discourage some of our more curious wildlife from taking them off the tree and playing with them.
So for our long-term goals, the Friends Grant enabled us to continue the inventory and monitoring of wildlife along the I-5 corridor, which started in 2021, and provide biodiversity data and wildlife images and videos to our partners. And for our short-term goal, the grant allowed us to maintain the cameras over the summer and complete a seasonal analysis of the crossing site using 1 year's worth of data. So this is our study site. It is a 10-mile stretch of I-5 between Ashland, Oregon, and the California border. For reference, the red star on the inset map is where we are right now at SOU. Currently, we have 27 cameras deployed in various habitats, elevations, and distances from I-5 along this corridor. So this graph is a way to represent what wildlife species we see and how frequently we see them. It was created from our larger ongoing data set and features 17 mammal species ranging from small to large-bodied and our one bird species, the wild turkey. On the y-axis are the camera locations from north to south, and on our x-axis is our capture rate, which is one way to measure how frequently we see species. So each camera bar has smaller, different colored sections. Each of these sections is a specific species, and the width of that section indicates how frequently we observe them. So for instance, the gray sections at the end are deer. The sections have a dotted outline on them for clarity because we found out a few hours ago that gray does not show up on this projector. So they will be here on this slide and they will disappear. But so at a glance, you can tell by how many of these gray sections there are, how wide they are. And so we observe a lot of deer and we see them almost everywhere. But for this presentation, we wanted to focus on these cameras here because these are the cameras located in the monument. So here are the monument camera sites. We have Bear Gulch in blue to the north, Mariposa Preserve in teal to the south, and the crossing site in yellow right in between. So when the monument was created in 2000, it was done so specifically for its biodiversity, which is something we wanted to highlight through wildlife species, again, primarily mammals, with two relatively simple types of analyses. So first, we'll talk about species richness, which is the number of species found in an area. And on the graph, it's represented by the letter S at the end of the bars. So as we mentioned before, we have 27 cameras deployed along the corridor. And of the top 10 areas with high species richness, 7 of them are found within the monument, which are the ones with the black boxes on the graph and the red boxes on the map. Our second analysis is a species diversity index represented by the letter H at the end of the bars, with higher values indicating higher species diversity. The index takes into account species richness, which we just talked about, and the relative abundance, or how evenly individuals are spread among those species. For example, Mariposa 4.5 at the very bottom has a lower index value of 0.71, but it has a species richness of 12, right? And that's due to the sheer amount of deer that we see there. And again, similar to species richness, 7 of the top 10 cameras with the highest diversity index values are found in the monument. And when we talk about the biodiversity of the monument, we see a variety of wildlife in this relatively small area. Right, so we see rare species like the spotted skunk. We see ringtail, another rare species. Oh yeah. We see Pacific fisher, again, another rare species that resides in the monument. We also see common species like bobcats throughout the entire area. We also see black-tailed deer, one of our large-bodied mammals. And we see elk, which is the largest mammal species we have in the monument. We also have large predator species like cougars that are seen throughout the area.
I was gonna be mad if you guys didn't do that.
And we have black bear. And as much as we're interested in what they're doing, they're also interested in what we're doing out there.
All right. As we stated before, we have cameras specifically located on the crossing site itself. These are designated as SOU 8, 9, 10, 11, with SOU 8 and 9 located on the west side of the highway, and SOU 10 and 11 located on the east. These cameras have the unique opportunity to monitor this area before the crossing site goes in. And so after, we can then take data that we get from these cameras and compare it to data we get after the crossing goes in. Specifically, these cameras were activated in fall of 2023 and hold much needed data to understand this area. From these 4 cameras, we can get many different things such as capture rate percentages, seasonal analyses, abundance ratios, and more. Specifically from this grant, we wanted to look at a seasonal analysis of the crossing site. Now, this is taken from 1 year's worth of data from when the cameras were activated of fall 2023 to fall of 2024. Now, these cameras are still active currently, but this graphic up on the screen is only that 1 year's worth of data. On the y-axis, you can see the capture rate per season, and on the x is what each species is. Each season is then color coordinated, as you can see in the legend on the right. Now, this analysis allowed us to see what's moving in the area and when they are moving. Specifically, we found that 3 species only used this area during 1 season, which was spring, and this was black bear, Douglas squirrel, and wild turkey. These images are specifically captured from our cameras, with SOU 8 capturing the black bear and wild turkeys, and SOU 10 capturing the Douglas squirrel. The photos with a red box to highlight where the species is are prime examples that these animals don't always pose for us. We often have species blending into the environment like the wild turkey, or blob running across our screen that we somehow have to identify like the Douglas squirrel. Second, we found that 2 species use this area all year round, and that was jackrabbit and striped skunk. These 2 images were taken from SOU 8, but it's important to highlight that these 2 species were captured in all 4 of our cameras at the crossing site, highlighting their abundance in the area. Finally, I want to highlight 2 major findings that we found from this 1 year's worth of data. Out of our 27 cameras, we have 18 relevant species that we monitor constantly. Out of those 18 species, these 4 cameras captured 10 of those species and 4 out of our 6 predator species, only excluding fisher and cougar. Now, I want to highlight again the short time scale that this data set is, and also the small spatial scale that this is. This is, again, 1 year's worth of data, and yet we captured 10 of our 18 relevant species, which is amazing. And second, this is a very small area we are monitoring in the monument, specifically the crossing site, with SOU 8 and 9 mounted almost on the same tree, and SOU 10 and 11 only 40 meters apart, highlighting the unique biodiversity of this area and the amount of movement that these animals do in such a small scale of the monument. Also showing that the positive effects of a wild crossing could have in the area.
So to wrap things up, the Friends Grant helped in our ability to maintain the camera locations, collect preliminary crossing site data, and contribute to the larger working data set over the summer. And we were able to complete a standard operating procedure for this project, and which can be used in the future. Our project highlights the biodiversity of the monument and why the monument makes an ideal location for a wildlife crossing. So thank you to Dr. Karen Mauger, our mentor for this project, and can't thank you enough for everything you do for us. Thank you to Dr. Bernie Bosco from the Computer Science Department for helping develop our data pipeline and integrating machine learning into this project. We didn't cover that aspect here, but there's a whole other technological side of our project that we do. Thank you to Charlie Shells, who started the wildlife inventory and monitoring along I-5 in 2021. Thank you to the Southern Oregon Wildlife Crossing Coalition for all their support and what all they do for the wildlife crossing. Thank you to Friends of Cascade-Siskiyou National Monument for supporting scientific research and giving us this opportunity to share ours. And thank you everyone for being here. And with that, we will take any questions. You can sometimes, we don't really focus on, but sometimes if they have identifying marks, sometimes the bucks will have certain types of antlers, or if they have certain markings, you can.
Yeah.
Other than that, not really.
getting a way to identify it would be really cool because like that would change our capture rate because like we have a couple cameras located in culverts and we see a lot of bobcat, but like it could just be the same bobcat going back and forth. So it'd be kind of interesting if we could figure that out, but we'd probably need something like a tag or like something of that sort. Or maybe Bernie could figure out some facial rec. I don't know. That would be really cool, but I feel like that's way above her pay grade. Or a spot pattern, maybe.
Yeah, bobcats, I know what you can
Yeah.
identify with spot patterns.
I kind of think of this like a crosswalk when we try to cross a road. I'm curious how animals know that that's there. They just learn that over time to funnel into that one small little area. It seems like, I mean, just curious how they learn that or how well they learn that.
Yeah, so one of the things that sort of goes along with it, we didn't talk about it too much, is that you put fencing up to try to like funnel them.
Yeah. So like there'll be 2 miles of fencing on each ends so that hopefully the animals will funnel to it and then slowly learn that you can pass there. And then the fencing will also keep the animals inside the funnel and keep animals that are outside of the funnel able to jump in, which as you can assume, that's going to be difficult, but hopefully, and after time, they will learn that they can cross here.
And this has been replicated in other places, I'm sure, right, with success.
Yeah, major success. We have in Oregon, we have a couple underpasses that have seen success, but this will be the first overpass.
I was excited by all the videos where you see different behaviors, you know, things jumping, like one was chasing prey at one point. I guess do you have any plans or have you done any like really basic analyses on any behaviors or prevalence of behaviors of species or anything like that?
I want to.
Yeah.
I like every single time we're like analysis, I'm like, if we did a behavioral analysis, what can we figure out? But we just haven't yet.
Yeah, we kind of have ideas, mostly concerning animal behavior around the culverts, about what animals are in the area, what animals will use them. But that's a lot of, funding type of, yeah.
Like we do have for our information slide. This is one of our culverts that we got a bobcat mom with 3 kits. There's a third one way back there. And so it'd be cool to like figure out that stuff.
I'm also wondering about data availability. Will the data be widely available so that maybe other researchers could do a behavioral analysis?
I think that's a question for Karen.
Yeah.
So far, we've kept the data mostly in-house, but there are a ton of camera tracking networks. And so I started getting in touch with some folks. And I think, because this project is a long-term one that we want to be careful that we're able to like protect sensitive data and publish on. We so far haven't shared it, but eventually, ideally, this would contribute to the networks. Yeah.
I guess this kind of goes back to the animal. Anyway, sorry. I'm curious what you guys think. Yeah, I know you said that there weren't very many predators in the main area that you were looking at, and I'm wondering how that would change as animals are essentially funneled down this area.
So there's not a whole lot of research. I think I've found like 4 or 5 research articles, and from what they can tell, it's called the predator or prey trap hypothesis, right?
Yeah.
That predators will sit. They haven't found evidence of it so far, right? It's still like there's still a lot of unknowns, right? Because like wildlife crossings, not a lot of data has been done before them. There's a lot afterwards. But yeah, that is one of the concerns, is if predators will learn to just sit there.
You could it's kind of a question, but could you look at some of the data you've gotten at the existing crossings, like the culvert and the, Mount Ashland exit, and make some correlation about what you're seeing as far as the number of predators and prey and frequency and timing of year?
Yeah, there's still some things like those types of analyses we haven't had time to do. We did do one, which was basically like species community, like what what's the word I'm looking for? community, species community or something. But it was basically like, do we see major differences in these different habitats around the culverts, like far away from them? And we did find some correlation that there are like different. But yeah, doing like a big one we haven't quite time yet to do.
It's also important to highlight that like different animals use the culverts. Often our bigger predators don't like to be confined. So like we've done, like I said, this project has been going on since 2021. And actually this year was the first year we got a bear going through the culvert, which we haven't seen before. Like cougars and bears normally look at the culverts and just like, no, I don't want to go in them, and then move on. And it's mostly the bobcats and the foxes that use it.
The ringtail was such a surprise to me. I didn't realize they were in the monument.
Yeah, how many ringtail have we captured?
My question.
That one is, I believe, the only one in the monument. We have a few other ringtails, but they're closer, I think, to like Mount Ashland.
We do have like one, at least I think, we haven't analyzed the data. I think he's one that comes every year on the railroad, so that's outside of the monument. But yeah, we've captured, I think, in 4 or 5 different cameras a ringtail. So they're definitely around.
Yeah, we don't see them all.
We don't see them often.
You can show for this presentation, your data was around where the crossing is going to be is 4 cameras right now. Are there plans to proliferate cameras east and west and then north and south from those locations before the crossing's put in and then probably after it's put in?
We would like to, but that's another of the funding, right? Trying to maybe build more of maybe an occupancy model around there. Yeah, it's kind of depends on if we get funding or not.
Yeah, we'd definitely like to put more.
Yeah, yeah, you can't have enough.
So the Southern
Oregon Wildlife Crossing Coalition,
yes, that giant word, made a humongous report and had, I think it was 7 different crossing sites to determine that could work. And then this is just the one they chose.
Yes. So yeah, so I mentioned Charlie Shells, who started it. He was the monument ecologist that worked for the BLM. He has since retired, but he was the one that originally started putting out cameras all along I-5 to try to figure out like where would be the best place. And Mariposa was chosen because it has high biodiversity, but also it would be the cheapest place to put a crossing because Bear Gulch actually has higher biodiversity, but the terrain is very rough and it would be very expensive to put a crossing there. So they determined that Mariposa would be the best.
And the funding for this is already extreme. It's about $30
million. $37 million. Thank you.
Another question, but someone on Zoom shared an anecdote that they had a ringtail on their backyard camera a couple years ago near Lithia Park. So,
oh, nice.
Yeah, they're around.
That's it.
Good.
Thanks. Thank you.
Great. Well, thank you again to all of our wonderful presenters and also for our audience. We really appreciate you coming out and learning with us. Yeah, thank you all for your support through either attending events. And if you would like to connect with the students, they'd probably be down to chat with you after this. They don't have to get out of here real quick. So feel free to stick around and chat if you would like, have some more food out there. And since we have so many of our community members here, just want to say briefly, as most of you are probably aware, we are facing unprecedented cuts to federal agencies, and that does include the Bureau of Land Management. And while the majority of our funds are not reliant on the government, they do give us a portion to support our programs, including the Friends Research Fund. And as BLM presence and maintenance in the monument will likely decrease, we'd like to remind you that we will continue offering our programs, including our hike and learn programs, our interpretive rangers, available for free and to the public. So just a reminder that that is not going away. And also just to say that it's truly a time for the community to step forward to support the continuation of services such as the info station, our educational programs and stewardship efforts. So if you can, and you would like to donate, you can do that via cash, check, or card on our website, or you can talk to any of our staff members or board members about the things that I just mentioned, or, you know, about anything in general. So yes, thank you again for being here, and I hope you have a wonderful evening.